Okay, so here you are given the graph, and we are tasked with the problem of writing the equation. So what I would do is, you know that it's going to have an x quantity squared and a y quantity squared, and that's going to equal r squared. So you're kind of using that standard form. And the first thing you want to do is find your center. So it looks like the center is right there. So in this case, my center is negative 3, 3. So negative 3, 3. So when I go to put that into this, I do the opposite. So it'll be a plus 3 with the x and a minus 3 with the y. And then my radius is 1, 2, 3. So here r equals 3 as well. And so now I don't put a 3 there, I put a 9, because remember it's r squared. So I have to, just like before I had to take the square root to get the radius, well now I have the radius, so I need to square it. Alright, very similarly for number 5. The first thing you want to do is kind of find your center. So it looks like my center is right here. I kind of was putting an X on it to find my center. So it looks like the center is 4, negative 6. So if it's 4, negative 6 as my center, then I do the opposite. So it's going to be x minus 4, y plus 6 for that equation. And then my r value, let's see, that's 1, 2, 3, 4. So here r equals 4. And so it's going to be a 16 down there. So remember, you have an x quantity squared, a y quantity squared. You do the opposites for the center, and then you have to square the radius for right there. Okay, so this is on the second page of your notes. Now basically we are doing the exact same thing, only I wrote out some information and you have to give the equation. So before where I gave you the graph, now I'm just giving you some other info. So it's kind of like I'm giving you this info that I wrote out, and now you just don't have the graph. So here, if your center is that, remember you're going to do the opposite. So you need an x squared term, so it'll be x plus 4, because I do the opposite, quantity squared, plus, and then it's a y minus 3, because I got to do the opposite of that, quantity squared, equals, and remember this is r squared. So if the diameter is 10, that means that the radius is 5, so that means that this number is going to be a 25 right there. All right. And very similarly for this one, again, your equation for a circle, there's going to be an x squared, there's going to be a y quantity squared, and it's going to equal r squared. And then you just drop in the opposites there. So it'll be a minus 2, a minus 5, and you square the radius, so you get a 49 right there. And that's beautiful. Okay. And then, does the point 9, 5 lie on 6 or number 7? Justify your answer. So if this, if this was the previous one where I had a graph, you could sketch those out and see which one makes sense. Or if you don't want to do that, you can always just test. So you've got the equation. So if I said if I plugged in this for the x, right, because this is an x value, that's a y value, so you're going to plug those in. So I'm going to kind of test number 6 first. So if I plug in x equals 9, 9 plus 4 is 13. So 13 squared plus, if I plug this in, 5 minus 3 is 2. 2 squared equals 25. And I always kind of put, like, when I'm testing something, I like to put a little question mark over that, because I'm seeing, does that equal? Well, do you think that 13 squared plus 2 squared is going to be 25? No, because that's like 169 plus 4. That does not equal 25. So I would say that 9, 5 does not lie on number 6. But now let me just test number 7. So if I plug in, again, x equals 9. 9 minus 2 is 7. So 7 squared plus, if I plug in y equals 5, 5 minus 5, oh, that's 0. 0 squared is 0. So 7 squared equals 49. And again, I just like to put a question mark there. So 49 equals 49. That is true. So I can conclude that the point 95 lies on this circle here. And again, make sure you know how to do that. That is definitely on your test. Okay. So now, how are we going to graph something that looks like this? Those other circles, it was really easy to kind of figure out the center, and once you know the center and then the radius, you can graph it. But we said as long as something has two positive squared terms with equal coefficients, that we, would know that it's a circle. But how do I graph this circle? So in comes what we call completing the square. And you did it a bit in Algebra 2 when you graphed quadratics. We're going to have to kind of double complete the square now. So basically you've got this equation. And again, you know it's a circle because there's two positive squared terms with equal coefficients. So what you want to do is you want to get your x junk together, get your y junk together, and make sure your number is on the right-hand side of the equation. So what we're going to do is we're going to add a blank and a blank. And then you're going to add plus a blank and a blank to the other side. So here we've got this plus a blank, this plus a blank, and then if I have two blanks on the left-hand side of the equal sign, I need two blanks on the right-hand side of the equal sign. Okay, so to fill in the blank, this is what you're going to do. You take half of this term, then square it. So half of 6 is 3. 3 squared is 9. So I put a 9 here. Then half of this is 2. 2 squared is 4. Okay, let me just repeat that one more time. To fill in the blank, so yeah, I might highlight this or something. The blank, you take the b, you cut it in half, then square it. So when I took this, the b, remember, is the coefficient on the x or the coefficient on the y, just the linear term, not the squared term, on the linear term, the one with just the variable. You take that 6, you cut it in half and get 3. 3 squared is 9, that's where that came from. Here, you took 4, you cut it in half and got 2. 2 squared is 4, so that's where that came from. Whatever I add on the left-hand side, I need to add on the right-hand side, so I also add a 9 and a 4 over there to keep the equation balanced. So the whole point of completing the square is because I want to get something as a quantity squared. That's the whole goal, because once it looks like that quantity squared, then it looks like I can graph it, right? If I have a quantity squared, then I know how to graph that. So if you were to think about how you would factor this, okay, well, that is the same thing as x minus 3 times x minus 3, right? If I FOILed that out, I'd get back to here. Well, the nice thing about this is I can write that as x minus 3 quantity squared. That's what's going on. Very similarly, if I factored this, I'd get y plus 2 times y plus 2. Well, that's the same thing as y plus 2 quantity squared. So what you're doing when you're completing the square is you are taking something and making it a perfect square. Basically something times itself. That way you could write it as a quantity square. So this here, this would be a circle. Okay, it would be centered at 3, negative 2, and it would have a radius of 5, and then I'd be able to graph it. So it's kind of an extra step. Okay, so here it says, find the center and the radius of the circle over here. Okay, and what does it say? Sometimes you'll need to rearrange it. Yes, so again, what you want to do first is make sure your x's are together and your y's are together, and then you add a blank. If you have 2 blanks on the left, you're going to need 2 blanks on the right. So you kind of keep your x's with x's and your y's with your y's. Again, to fill in the blank, you take this 10, you cut it in half and get 5, and then you square it. That's where that 25 came from. It's the b value cut in half, then squared. Very similar, you do it now with the y groups. So negative 8 cut in half is negative 4, but negative 4 squared is 16. So that's where that came from. You got to keep it balanced, so whatever you add to the left-hand side, you need to add to the right-hand side of the equal sign. So you get to this. Now, this is a perfect square. I know most people don't think of it, but a math teacher sees that and says, oh, that's a perfect square, because it's x minus 5 times itself, so x minus 5 squared. The shortcut, if you will, is you know it's going to be the square root of this is x, the square root of 25 is 5, and you match the sign. So if this is a minus, that's a minus. Right? So here it'll be a y, you match the sign, a minus with a minus, and then you take the square root of that as 4. Okay? And then you add up these numbers, kind of, you know, just simplify. Negative 32 plus 25 plus 16 gives you a 9. So here the center would be 5, 4, and the radius is 3. Okay? So let's take a look at this first example. Again, I'm going to rewrite it so that my x's are with my x's. So I'm going to have x squared plus 2x plus a blank. Okay? Then I'm going to do my y's. So y squared